Carbohydrate is kind of like the name implies. It is a carbon and hydrated compound that follows the general formula of a certain amount of carbons and hydrogen at 2 times the amount of the oxygen in the formula. And these are molecules that are found in sugars, starches, fibers. The way that we can recognize a carbohydrate's structure is by looking for 5 or 6 membered rings. So 5 or 6 atoms that are linked into a ring shape. And each one of those rings contains oxygen atoms and also has alcohol functional groups that come off of the main ring. Some of our carbohydrates are single rings, while others are 2 or more rings. And the difference between that is that if we have single rings, those tend to be more like sugars, easy to break down. And when we start having multiple rings linked together, then we get into starch and fiber that are a little bit, take more energy for our body to break down. So what do they look like? When we look at our ring structure, here is an example of glucose. We have 5 carbons in our ring and 1 oxygen that makes up our glucose. You'll also notice that there are hydroxides coming off of that ring. If we look at fructose, fructose is a 5-membered ring made of 4 carbons and 1 oxygen. And again, we have the hydroxides that are coming off of the ring. Now, the direction that those hydroxides face determine the type of sugar that it is. If we start combining these ring structures together, we can make some new molecules. So here we have a glucose attached to a fructose. And we make a new molecule that we refer to as sucrose. So it's a glucose and a fructose attached. We have, this actually is lactose. And lactose is galactose. You'll notice this is a little bit different from our glucose because we have hydroxides facing different directions on the ring, but it's galactose and glucose that are attached together to make lactose. So this is the sugar that is commonly found in milk. If we start stringing very long chains together of glucose, then we make something called cellulose. And cellulose is what holds many plant fibers together. So when we get lots and lots of glucose molecules, then it becomes even harder for our bodies to break these structures down. Now, you do not have to recognize the difference between glucose and galactose. That is not the point here. The point is that our carbohydrates are these ring structures, and we can build them together into different molecules. So we do want you to be able to recognize the difference between a carbohydrate, which contains these rings, from a protein, which is a string of amino acids, and a fat, which is the long carbon chains.